Hello and welcome to episode 29 of the eBPF and Cilium Office Hours live stream. Welcome if you're watching us live. As always, I'd love to hear from you. Tell us where you're watching us from. Say hello. And as always, we'd love to have your questions as we go through today. So before we get started with our main topic, which is going to be about BPF LSM, let's just run through a couple of headlines related to what's been going on in the world of Cilium and eBPF. Hi to Quentin. He's our moderator today, so thank you for stepping in to do that, Quentin. So the first thing I have on the headlines now, the show notes, as always, are let's try and make that a bit bigger. There we go. The show notes are on HackMD. So if there are things that we mentioned during the show and you want to edit them as we're going through, you can find the link there on HackMD at echo-live. And I'll also mention that if there are things that you would like us to cover in future editions of the show, we're always interested to hear what you'd like us to cover. So we do have that repo on GitHub, isovalent/echo, where you can raise issues and let us know what you'd like us to be speaking about. Hi to Dinakaran P from India. Hello. Hi to Rahul, also from India, Bangalore. Hi to, I don't know whether to pronounce that, Yuka or Yuka from Finland. Good to have people joining us from around the world as usual. So what is going on in the world of eBPF and Cilium? Coming up very soon in the world of Cilium, there will be release 1.11, and the second release candidate is already out. So if you're interested in kicking the tires, cutting edge of the new upcoming version, you'll find that on the Cilium GitHub as usual. Obviously, if you do find any issues, we'd be more than happy to receive reports of those. And the full release will be coming out in a very short amount of time. There's going to be a full blog post describing all the new features. So watch out for that coming your way soon. In terms of blog posts, we've got a couple of blog posts to share this week. One is from Grant Seltzer, our friend Grant, who has been writing about how the libBPF documentation site has been put together. That's a relatively new documentation site, as I understand it. And he's described in this post how you can contribute if you have improvements to make to that documentation. I guess like everything in open source, it's a collaborative effort. So this post might help you make contributions if you would like to do that. Another blog post that I'd love to recommend is from my colleague Natalia. So she's written this great post about detecting container escapes with eBPF. So check that one out as well. Also, I think I mentioned a couple of weeks ago, but I'm going to mention it again because they have been going really well. We've been holding some weekly install fests and AMA sessions to introduce people to Cilium. So if you're considering using Cilium, but you have some questions, or if you want to walk through the process of installing it with a small group of people and have your questions answered live, both of those activities are happening every week. So you can sign up for time slots. The Install Fest is happening alternating between European and US friendly time zones. And I think, as usual, if the times aren't working for you, we would be really interested to hear that. I would say probably the best place to raise that would be on the Cilium and eBPF Slack. I hope you're all already signed up to that Slack because there's a lot of really great conversation and help that goes on there. All right, so I think it's probably time for us to move on to the main topic for today. So I'm going to welcome to to the show, I'm going to welcome KP Singh. So welcome to eCHO.
Hello.
Thank you so much for joining us.
Thank you for introducing me, Liz, and thank you for having me over. This is very exciting to talk live for the first time on YouTube.
Oh, it's great to have you, and I'm sure our audience will be kind, and they will ask you lots of great questions. And yeah, so we're really honoured to have KP because he's such an expert. He's a kernel maintainer, and he's been working on BPF LSM. How long have you been working on that? I think it's been a focus for a while now.
Yeah, it's been about slightly more than 3 years since we started working on it. Slightly more as when we started it internally and then introduced it to the Linux kernel audience. So I would say 4 years.
Wow, that's that's enough time to build up some real deep expertise. And we should probably mention that you're a staff software engineer at Google, and you're based over in Switzerland, very close to where some of our isovalent colleagues are as well, I believe.
It's really nice to see that there are a lot of BPF people in Switzerland. Something that it came as a pleasant surprise. We have a budding kernel community in Zurich as well. In Zurich, I'm a part of the security and privacy organization in Google. I lead the detection and response team, and I am also responsible for operating system security in Google production in general now.
Wow, that's a big responsibility. So yeah, keeping all our communications and data all safe from harm. That's fantastic. So I guess in order to do that, you've been really involved in developing BPF LSM. Presumably, you're doing that to actually protect Google's systems, right?
Mm-hmm.
And I think maybe we should start by just telling people what. So BPF LSM, the LSM stands for Linux Security Module, right?
Mm-hmm. Yes. So I think the first thing we need to have people aware of is what is LSM, and I think people may not have heard the word LSM that often, but this thing, when you say SE Linux or when you say ARMOR, it rings a bell. And LSM is the framework in the Linux kernel on which these popular security policy software is built on. So it's called Linux Security Modules. Unfortunately, like naming goes in the Linux kernel, it is not very modular. So when I need to build a new LSM, I need to write kernel code, I need to recompile the kernel, and I need to restart my machine and so on. So it's, even though it is Linux security modules, it's not very modular in nature. But like the goal of LSM is to basically write policies that prevent users from doing some malicious stuff, or prevent privileged users from doing malicious stuff.
So I guess that leads very naturally to us thinking of BPF programs that we can load into the kernel, the contrast of a security module or any kind of kernel module that, requires a significant amount of development, contrast with BPF program that we can just load dynamically into the kernel.
Exactly. So what BPF is really, really good at is it takes an inflexible kernel sort of API, right, which is traditionally being configured with policy language. For example, SE Linux has a policy language, AppArmor has a policy language, IP tables had a policy language for that matter. And maybe in the future, you will see audit in this space as well. So you take something that is configured by a rigid policy engine, and you remove the policy engine, and you bring in the power of eBPF there. So you can configure this API with your own eBPF, and you have eBPF maps. And of course, along with that, it brings the aspect of safety because it is verified at load time. And then you can control your user space logic with your in-kernel logic without needing to recompile the kernel, which makes it easier to deploy firewall logic or load balancer stuff, and in this case, security as well.
I think something that was a new realization to me when we were talking about this sort of before the show was that the LSM, that there is an LSM API. Mm-hmm. So my understanding is that's the set of hooks within the kernel. Is that right?
Yes. So it's good that you asked that, because I missed that a little bit. There are these hooks are basically where the kernel needs to make a decision, right? There are about 200 of them. They sit slightly higher than the syscall, slightly at a more semantic level than the syscall API. For example, you have maybe two syscalls, for example, to execute a process. You can execute a process with execve, and you can also do it with execve add. Now both go through the same LSM hook, and these LSM hooks are placed in the kernel where the kernel changes something to a Linux object. So for example, execution involves a file and a task, right? So whenever there is a process being executed in that semantic LSM hook, the kernel will have access to the file that is being executed and the task that is going to be created as a result of that execution, and the parent task, for example. Now, given this context, it can make certain decisions. Am I going to allow this execution to happen? It may also decide to do some annotations on the task and the file. It'll be like, okay, I made a note of you're doing this execution right now. Maybe further down, when you try to open a socket or something, I'm going to retrieve this information from the task struct and annotate this on the socket. So it's sort of a relational mapping between different objects in the kernel, and these happen at certain key areas. The real value is where these hooks have been placed in the kernel. If people have spent a lot of time figuring out what is the right line, what is the right function, is the object in the right space, are they holding the right locks? Because if you don't hold the right locks to the object may change, and you may have inconsistent behavior when you're doing this annotation or when you're making a decision, and you don't want that to happen.
So I guess for a lot of people who have had some exposure to BPF programming, we might want to contrast LSM to some of the other places where we can attach BPF programs. I think for a lot of us, certainly when I do Hello World, I'm typically thinking about attaching to a K probe. I'm sure we'll talk shortly about K probes for system calls. LSM hooks are, I guess, one of the big differences is this ability to not just see what's happening, but actually influence what's happening. Make a decision: is this behavior permitted or not? Which I think is pretty different compared to, let's say, K probes.
Exactly. So this is the ability to make a decision and reject actions. K probes are fundamentally, and K probes and trace points are fundamentally for observability. So you can hook at probably thousands of places in the kernel, and you can observe certain events. Now the first problem you'll run into there is like, where do I need to hook? Right? Like you don't know where should I hook at this particular function when I'm looking at a process. And you may figure, okay, this is the right trace point to hook for a particular process execution, and then some locking or something in the kernel may lead to inconsistent behavior. So that is the thing we touched about. Of course, you cannot make a decision. You cannot return saying, okay, you're not permitted to do this action from a trace point or a K probe. This is something that is especially available to LSM programs. And the other bit that I think this is something that was pretty exciting that Leo covered in his CNCF talk was that just these subtleties around where you attach to observe and to make decisions around a particular event can lead to very inconsistent behaviors. And these inconsistent behaviors can actually be exploited by attackers. So you're hooking at a trace point for process execution. Now, the kernel hasn't yet copied the data for the arguments, for example, for what it is going to execute. So you've read the arguments, and after you've read the arguments, and before they copied to the kernel, the attacker manages to switch the pages in the user space. And this is something that we call a time of check to time of use attack. And not knowing what places to hook in the kernel it makes you highly susceptible to time of check to time of use attacks. And this is what LSM helps you prevent against. And Leo did a really awesome demo in the CNCF talk on like, here is me attaching to a trace point. Here is how the attacker takes advantage of us hooking at the wrong surface in the kernel. And here is how LSM would solve this issue.
Yeah, I think we're linking in the show notes to the talk to Leo's talk that KP's talking about. I think I also got a link to the DEF CON talk which shows how that attack can be, or how that time of use to time of check kind of window can be exploited. So yeah, if you like seeing attacks, I think that's quite a fun talk. I'm just going to say hi to Russell. Good that you were able to join us. And Russell is asking if there's something like a flow chart for the order of hooks that could be attached to.
This is very interesting question, and I think this is what needs to improve in the LSM API interface in general. So we mentioned these 200 hooks in the kernel, right? Now, as a kernel engineer, I know that PPRM check security means that this is where I'm supposed to do process execution checking. Now we've made this surface available to users who may not be aware what PPRM is. It took me a little bit of time to figure out what PPRM is. PPRM means binary parameters, and I was like, okay, what does this got to do with process execution? There is a lot of historical context that is assumed when you read about these hooks, and when you read about the documentation of these hooks in lsmhooks.h, which is, I think, Liz, you've linked it in your show notes as well.
Yeah.
And they assume a lot of kernel knowledge. Now, what Russell is asking here is, what are the orders in which these hooks are going to be called? No, there is no information. The only information that exists there is the kernel code and your ability to sort of trace the kernel and figure out what hooks are being called in what order. And I think that needs to improve here. We need to improve the knowledge, or sort of simplify the knowledge, maybe with user space abstractions around this, that or archetypes in BPF programs that can sort of translate, or that can sort of make that knowledge that is in the brain of a kernel engineer available to somebody who's developing BPF programs, BPF LSM programs. I think this is
I feel like there's two levels of that even. So there's the being able to understand what those kernel, events and structures relate to, and how you could write the BPF program.
Yeah.
And then another level where, if you're a operations person, if you're trying to secure a cluster, a deployment, a machine, you don't necessarily want to know about those kernel events. You just basically want to be able to say, is this program safe to run, or is this network connection safe, or having policies that are at a higher level of abstractions. And personally, I think that's one of the really exciting things about eBPF, because we can, at a low level, build these really flexible and powerful and interesting tools, but we can also provide an abstraction that is more useful for somebody who isn't like day-to-day embedded in the kernel.
I think you got it bang on. Like there are two user journeys involved here, right? There's one that is the BPF developer, who's generally never looked at security, but they know how to write BPF programs. Even for them to figure out, like, what is this LSM hook? What are security blobs? What information can I annotate where? Is tricky. So we need to solve that issue. And then the second persona, or the user journey you talked about, is the security admin, who doesn't care about BPF programs. They care about, I want to audit this particular event. I want to see if there's something fishy happening on my system. And then, based on something that is fishy, that fishy sort of fingerprint of an attack, I want to block this action. So their user journey is basically observe, detect, block, right? And the other user journey is the core eBPF developer, who needs to know what these hooks map to. I wanted to talk about this explore, detect, attack a little bit more, because I think this is something that, when we were building BPF LSM, it was missing in the kernel. So the kernel has distinct APIs that are for observability, and there is these distinct technologies that you can use for enforcement, like SE Linux and AppArmor, but they're completely separate. So we didn't have one particular thing that could do both, that could do enforcement, and that could do observability. And I think BPF, not just BPF LSM, but BPF plus BPF LSM, ties all of that together into a single sort of set of programs, or set of language that you could use to do both things.
Yeah, I think that does make sense. And in my experience, a lot of security teams and platform teams, they quite often want that ability to audit first, make sure that if they have security tools that will block things, they want to make sure that they're not actually blocking legitimate behavior. So they want to go through an auditing phase first to make sure that their legitimate programs can behave as normal, and that they're not triggering any of these audits, and save the audits and then subsequently the enforcement for genuinely malicious behavior.
So this is an interesting point that you brought here, and this is that LSMs can, if you're not careful with LSMs, not just BPF LSM, but with SE Linux or AppArmor as well, you can shoot yourself in the foot. If you say like block all files from being read on the system with a BPF program or IC Linux policy, you're killing the system, right? You won't be able to read any file, and then your system is basically useless from there on. So of course, you need to at the BPF program level, you need to know when are you denying a certain action. And in order to be safe, when you're going to roll out a new policy change, you would rather run it in dry run mode and see, okay, how many times is this policy being denied, right? Is this actually being denied? You will have some sort of reproduction of an attack, right? And you'll run the reproduction and see if the BPF LSM policy catches that attack from happening. And does it reliably catch that? So that auditing phase here, or the dry run phase, is also very important when you're doing BPF LSM, or in general, any Mac policy enforcement on Linux.
We've got a question from Jalal. Hi, Jalal. He's targeted at Quentin, but I think we can try and answer it out loud as well. So in general, what's the news of Sleepable BPF? Is that something that you can speak about, KP?
Yes, so Sleepable BPF, I'll give some, for users who don't know what Sleepable BPF is, some background around Sleepable BPF. BPF programs have been in this, BPF programs have been in this non-slumber state for a long time. And non-slumber means that once you run a program, the kernel cannot preempt the execution of a program to do some stuff. And for LSM programs, this is a deal breaker, because when you're reading an argument vector for a process, this can run into multiple pages. Now, if you have a large system that has multiple gigabytes of memory, you are not likely going to go into a page fault while reading that memory. So you're probably okay. But if you have a large argument vector or a small memory or a combination of both, you may block at a phase where the kernel says, "Oh, I need to page out a page in memory that you want to read, but I need to stop you from executing in order to page in that memory." And this is, so it needs to put the BPF program to sleep while it does some other work, and then bring the BPF program back alive once the data is available. Now, this is something that Alexei implemented in the kernel, but there are only certain places where you can do this in the kernel. And this is the question that Jalal is asking, is, are these set of places in the BPF LSM, are they going to stay consistent, or are they going to change the set of these places where you can sleep in a BPF program? They're codified in the kernel, actually. We have a sort of a hard-coded list in the kernel that says these are the places where we can sleep. Now, there is some work happening. There is work happening on tagging sort of functions, tagging data structures. Rather than having this as a hard-coded list, the implementation will be better. But from a user experience perspective, I have a couple of things to say here. Like, look, with flexibility, there is going to be some changes that are going to happen over a period of time, right? But LSM hooks have existed for as long as Linux has existed, 20 years or so on, at least. And that's my rough idea of how LSM. And they change very little. So it's unlikely that LSM hooks are going to change. The sleepable behavior is going to change, but it may happen. And when it happens, we're going to look at, somebody's going to run a program. They're going to realize that we have an error message that is going to come forward when you try to attach a BPF, a sleepable program, to a hook that is not sleepable. And when we receive the error message, we're going to remove it from the set of hooks. But I would say the likelihood of that happening is very less. And when that happens, we might actually even discuss with the people who are going to mark these as non-sleepable as to why they're doing it and suggest alternative primitives. So,
Right. Yeah. So does that sleepable behavior only really apply to LSM hooks, or could it be potentially useful for other kinds of BPF hooks? I
oh,
don't have a use case in mind. I'm just wondering if that's
we
come up.
we have allow listed the sleepable programs, sleepable attachment points for tracing programs as well. So it's
Mhm.
not just LSM hooks. There are certain, like for example, there are certain helpers that you can only use in sleepable programs. So like copy from user is one where you're copying user space memory into the BPF, a ring buffer or a map. That is one of the helpers that you get access to only in sleepable programs, and you may want to have access to this helper when you're doing tracing as well.
Mhm.
So but then tracing is a very broad attachment surface. There are thousands and thousands of functions in the kernel. Now we've allowed listed very few of them. This is not an exhaustive list. So when people notice that they want to attach to a particular kernel function that is sleepable, uh, I would encourage them to reach out to us in the kernel community and then send us a patch. But if you don't want to send a patch, please ping us. Join the BPF office hours and have a discussion of what is the thing you're trying to trace there, and we can help you.
Mm.
We have a weekly office hours which we can actually link from the show notes as well.
Yes, let's add those in. Yeah. So, maybe you can tell us a little bit about what BPF LSM is being used for today. What kind of tools exist that are building on it?
So I think this is the area that currently, like people, large companies like Google, we have this, the first persona we talked about, the experienced engineers who know the attachment surface really well and who can build BPF programs. That is sort of one use case that is already ongoing. We deploy BPF programs for Mac policies.
Mhm.
But beyond that, we're seeing technologies come up. We saw Falco started using some BPF LSM programs. There is BPF Box, which is now renamed to BPF Contain. I remember seeing a presentation in eBPF.io, which is about limiting the surface of privileged sort of processes using Mac policies. It's
Mhm.
something that uses BPF LSM in conjunction with user space tracing. That was pretty cool to see, and it has an abstraction language on top of that, which is helps the second persona we talked about of somebody who doesn't really like dealing with BPF programs but needs a surface that can change without changing the kernel.
Yeah.
But like so that is the added benefit. Even though it is a policy language, but that policy language can be evolved without sort of requiring to modify the kernel. We've got Tracy, some sort of evidence of BPF LSM usage, and there is Cube Armor, which I have looked at briefly, but I've not gotten into depth. But there is an ecosystem starting to build around BPF LSM, and they aim at providing a better UX to somebody who doesn't have the in-depth knowledge of the LSM API.
Yeah, I mean, I think historically the LSMs that people are familiar with, like AppArmor and SE Linux, they do have a bit of a reputation for being hard to manage and hard to maintain. And I guess the hope is that with these newer generation of tools, because BPF allows that flexibility, we can build tools that are, enforcing, maybe having different enforcement rules for different containers or for different namespaces in Kubernetes, or however we want to cut things up. And that kind of thing is possible because you can make those dynamic decisions in BPF programs to say, well, what's the context of this event, and what policy do I want to apply?
I mean, I wanted to talk about like you mentioned containers there, right?
Mm.
Containers is an interesting sort of topic from a BPF perspective, and even in the security space. So the definition of what actually is a container differs from
Yeah.
one person to the other. And the Linux kernel community in the core engineers, like they don't treat container as a really sort of well defined boundary. There are namespaces. The names some collection of namespaces where you can call it a container. Now, when your definition of container doesn't match the policy implementer's definition of a container, you run into issues. Now, I think this is where BPF and BPF LSM is quite powerful there, because then you can choose to choose to annotate your tasks, your inodes, and your structs with namespace information that you think, or generate unique IDs based on a certain set of namespaces, and you can form your own container ID in BPF. This is something that has been a topic of like long-term debate and discussion in the Linux kernel. Like, we want to have container tracking, container ID patches, and audit, and it's gone on and on because people just don't. It's very hard to come to an agreement on what is the canonical definition of a container that Linux kernel should have inbuilt inside it. So this is where BPF is quite powerful, I would say.
Yeah. I guess that relates to what you were saying before about being able to kind of tag the kernel structures with kind of metadata about, well, whatever I suppose you want to tag it with. And perhaps one of the things you might tag would be, in my world, this is a container, or this is a Kubernetes pod, or...
So I'll give an example, right? Let's say that you think a container is something that just has a network namespace, a process namespace, and a C group namespace, right? So what you do in your BPF program is, when you see a new process executing, right, that has a different namespace than its parent on these three aspects. What you could do is, in BPF we have atomics. One of my colleagues implemented atomically incrementing operations in BPF. So you have a global ID sort of counter, and you atomically increment that. You generate a new ID when this criteria of a new container appearing forms in the BPF program. You can also augment this information by talking to your container manager. But let's say you don't even agree with the container manager from a security perspective on what a container is. You want to really have your own dynamic logic there. And then you can generate a new ID when you see a new container being formed, depending upon the namespace metadata that you bring out on the kernel, and then you can annotate the task struct. And then you can pass it down the process tree from there on. You can say, okay, this is your container ID, and henceforth, all the children that you will have will be tagged with this container ID, and you can do this with LSM hooks.
Yeah. That opens up a whole world of possibilities, and I really like the idea that, well, we don't all have to come to the same conclusion about what a container is in order to build container security tools, for example. That I think that's absolutely the right move. We have a question here from Dinakaran. Can I take a backup of a file and then delete it using BPF LSM hooks? I guess, can you delete a file from a hook?
I would say, I don't know, but I would say no. Deleting a file would not be. Backup of a file is interesting. I haven't considered that use case. You may be able to walk the IO vectors of the file and then copy data from the IO vectors into a map. It would be very cumbersome. I wouldn't. What is the use case? Why do you want to do it at the LSM hook? Would be my question, to be honest here.
Yeah. So, Dinakaran, if you can, well, first of all, I hope I'm pronouncing your name correctly. And secondly, if you want to describe your use case a bit more, then I'm sure KP can try and answer that. All right. So we talked a bit about, what the state of BPF LSM is at the moment. It's in pretty recent kernels only, I believe, right?
So yeah, we started, the first set of patches landed in 5.7. The major sort of functionality including BPF, sort of BPF sleepable stuff, and the local storage. Local storage are these security blobs. The annotations are possible with local storage. So before that, you couldn't annotate kernel data structures. All of that, I would say, if you want to use 5.14 plus.
5.14, yeah. Okay.
Dinakaran has, I think. Okay, there's another question.
Yeah. So, argument: BPF LSM Flexibility Power is an example. You can use kernel lockdown hooks. By default, kernel lockdown stops operations that modify the kernel image, including hibernation, but with BPF LSM. You can modify other operations. Sorry, you can block other operations that modify the kernel image, but allow hibernation.
Okay. So I think this is more of an example than a question, I guess.
Yeah.
It's actually pretty cool. I didn't think of this use case. This is that's one of the brilliant aspects of open source technology and having these discussions is that you get to learn a lot of new cool things as well, no matter how experienced you are.
I think that's absolutely true. I think it's whenever you build, well, anything or anything with an API, people will think of creative ways of using it that you never dreamt of, and that's certainly been my experience over the years. People are much more creative, and have different problems that they need to solve.
Awesome. Jalal, if you have some sample code, this is already on GitHub. It'll be nice for you to share us, and probably you can share it with me on Slack, or like we could also do it in the show notes. This will be super cool.
Brilliant. So what's next in the world of BPF LSM? Where's it going from here?
So let me pull out the right slide for this. So
actually, I meant to ask you. You had the KRSI logo there briefly. I think that name is that still a name that people are using?
So yes, I think people still use BPF LSM is a mouthful, and I don't think KRSI is a great name either, because naming and cache invalidation are two hard problems. But I think KRSI, the way I've sort of formed it in my head over a period of time, is KRSI is BPF LSM plus other things that you could do for security on using BPF on Linux. For example, let's say that you realize that the LSM hook is not sufficient for me to get a particular information, right? I need to use it in conjunction with tracing and with sleepable stuff. So all of this collection of tools, I've started calling it KRSI than just BPF LSM. The truth though is that it was like, okay, the BPF maintainer was like, okay, KRSI is not a cool name, and we should just call it BPF LSM because that's what it is. And then I adapted what KRSI stands for. But runtime security on Linux kernel can be done with BPF LSM, but also a lot of other things. And that's what I think KRSI stands for now.
Okay. Yeah. The I being what? Interface?
Kernel runtime security instrumentation.
Instrumentation. Okay.
Yes, yeah. I have.
Great. Thank you. Yeah. So we were going to talk about what's coming next. Yeah.
So I wanted to run through what is currently available and then highlight the gaps, like where the gaps are. So what we have currently is that you can walk pointers in tracing programs and LSM programs. This is possible by compile everywhere, compile once, run everywhere PDF pointers. PDF is this shrunk up draw format. You may want to read Andre's blog about Cori and BTF. We have the local storage stuff, which allows you to annotate kernel objects. And the kernel objects that are currently possible to annotate are inode, task, and socket. Local storage annotation currently is not possible in sleepable programs because map access. Local storage is implemented as a BPF map, and map access in sleepable is in the works. I'm actually working on it currently. Like I spent some time yesterday figuring out some RCU or locking stuff just to get that possible. So this should be coming soon. Atomics to generate custom identifiers is, for example, the container ID stuff that we talked about. You can generate your own identifiers in LSM programs, your own security context that is uniquely identifiable to a particular object or a particular concept. We talked about sleepable programs. This is, again, you can read user space data. You can an interesting one we added, I think this is something people may not be aware of, is IMA. IMA is this sort of integrity framework in the Linux kernel. It allows you to sort of verify executables and appraise. You can say that I know this executable should have a certain hash, right? And what we've done is, because when you enable IMA, it calculates the hash of an executable. We've created a BPF helper that can read that hash. So if you're into sort of binary fingerprinting for security in BPF, you can retrieve that hash of the executable using this BPF IMA helper. Again, only available for sleepable programs because of IO here.
So would you then maybe check that hash against some list of known good executables?
Exactly. You can or you notice that some particular executable is known bad executable. You can deny the execution of that. So In conjunction with IMA, the BPF helper becomes quite powerful. You can build your own logic around the fingerprint of an executable or a file.
Mm.
And then what we have in other BPF programs as well is the ring buffer, where the BPF ring buffer is super cool. It allows you it's pretty fast compared to the perf ring buffer, and then you can communicate with user space. So dump your arguments there, form your own logic on when you want to truncate, when you want to chunk arguments. There's a nice talk by my colleague at the eBPF Summit about how we did chunking at Google for argument vectors. And this essentially allows you to guarantee that you have, no matter how big the argument vector gets, you get all of the argument vector back into user space. And you can assemble it back from the BPF ring buffer. So I think this is what is currently there, but there are some things that are definitely missing here. So I think the fundamentals, before we talk about what we're building next in this space, I want to talk about a fundamental issue with Audit and Mac. Now, our initial proposal was that BPF LSM should be able to do both auditing and should be able to do Mac logic as well. And for a certain number of operations, this is actually true. But for some, we realized that the place where in the kernel where you want to take a decision is not the same as the place where you actually want to do the logging. So you want to do the check whether you're allowed to do something really early on in the life cycle of the operation. So am I allowed to open this file? Even before the file is opened, you want to do the check whether I'm allowed to open this file. But when you want to audit whether the file has been opened or not, this is a simpler one. There are more complicated things in the kernel, for example, kernel module loads, where this is very apparent. And then once you've opened the file, there could be other errors that you were unable to open the file, or you were like the disk went bust. So the audit event that you generate for that is probably after the operation has successfully happened. So what we want to do in order to truly expose the audit capabilities, of course, you can do auditing with tracing as well, but there is this corpus of knowledge that audit people have figured out. These are the right places that you can hook into the kernel for auditing. Similarly, for Mac, there are correct areas for auditing as well. There is some overlap, but the overlap is not 100%. So what we want to provide is the same thing. You have, instead of the LSM API, you will have the Audit API. You have an existing inflexible policy language for audit, and you will want to change that into like a BPF, bring the power of BPF to audit, and then you can build tools around that, and then combine BPF programs for audit and LSM is when you get true sort of single unified interface for audit and Mac in the kernel using BPF. That would be one project. There's a lot of discussion that is happening. We don't know what is the right way to go about it. We've been debating about it both internally with the maintainers. On Linux Plumbers, there was a talk that I gave about this, and we discussed a few alternatives. And I think the discussion is going to go on until we reach the best way to modify or expose the Audit API to BPF.
And will that be called something like BPF Audit? Or
naming is not my forte, so I'm going to stay away from that.
But it wouldn't be part of LSM specifically. It would be a separate.
I think so. It may be it may be a separate program. It may be such that we don't create a new program type. We modify tracing in some way that it exposes audit hooks and provides certain guarantees to them. It's all currently up for design and discussion. So if users here have some thoughts, that would be cool to share that as well.
Actually, really interesting question here from Marco. So we talked a bit about these annotations on kernel structures. What's the advantage of that over using a BPF map? And he's suggesting mapping a process ID to the structure.
So an interesting one for a PID there is like, first of all, PIDs are reused. So you will have to come up with a unique identifier. You could come up with a unique identifier when with the atomics stuff, like you could generate a natural key of some PID and something. The issue there is you need to manage this map with the life cycle of the process. Now, Local storage comes with the concept of security blobs, and they live and die with the objects. You don't have to actively manage them. So when a task is born and you annotate the task, you don't have to worry about the task going away and you cleaning up the storage when the task goes away. When the task dies, the local storage will automatically be freed. So that is, it sort of makes it more robust and sort of more immune to sort of leakage when you forget to evict the map.
Yeah, that makes a lot of sense to me. And I guess you always know that annotation is, it's going to carry on with that structure. There's no possibility of it somehow getting out of sync as it might if you stored it in a separate map.
Yep. That's a really interesting question. The next one.
Okay, another question. So the existing kernel module, Linux security modules like AppArmor and SC Linux have been, they have the advantage of having a predefined policy construct in kernel space. So do you think that BPF LSM that depends on BPF helpers to fulfill these user-defined flexible policies could be used today equally well? I think
the answer is an honest no. Like SE
yeah.
Linux and AppArmor have taken multiple years to evolve, and of course there are missing features. It is not just going to be helpers. It's going to be a lot of other things that we need to build to get that to work. SE Linux and AppArmor are useful because there's a lot of development that has happened, and there is no magic wand that can make BPF LSM like have the same capability in a couple of years. That said, there are use cases where BPF LSM is better than SE Linux and AppArmor, and this is because it allows you to pick the hooks that you choose to sort of activate. Now, think of a production environment, right? And I'm working on some patches that reduces static call overhead of LSM. So imagine a system where the base overhead of BPF LSM is 0, and then I choose to only audit files and processes and nothing else because that's what I care about. Or I choose to have a policy built around files and executions and nothing else. In this case, you have much greater control over what are the performance characteristics of the system, right? And actually what the policy is. But it doesn't replace something like what AppArmor and SE Linux do for a user-facing distro, right? At least for now. They have, and I can talk about some things we probably need to do, but that would not be an exhaustive list. We need to do a lot more than that.
Yeah, I think this is really the opportunity for some of the tools that we mentioned before to kind of provide people with, I don't even want to say equivalent, but kind of different, better policy languages and ability to configure things to solve today's security problems and to have that flexibility to kind of, I'm guessing, lots of different organizations have different policy requirements, and that's going to be the beauty of these modern tools, I think.
I think what we want to do is when you say the policy, Rahul mentioned they have the disadvantages that their policy construct is defined in the kernel space. That is the area we want to focus on. We want to have the policy construct outside the kernel space. We want to bring more people who are much more experienced at building a UX around security, around how users want to interact with the system than a kernel engineer would. Whereas SE Linux and AppArmor are written by security and kernel engineers. So you need the intersection of kernel engineers and people who know good policy UX is very thin, right? And what with BPF, what you do is you bring a lot more people in because you don't need to know much about the kernel to develop a good UX around this. And that is what I think should happen over a period of time.
Another question from Jalal asking whether there's any news about loading BPF programs at boot.
Yes, this is already possible. You'll have a look at Alexei's work on user mode driver is what it is called, and you can have BPF programs that get loaded at boot time. This is an important question from a security perspective, because these annotations that you form on that you want to do on these kernel objects, you want to do them as early in the boot cycle as possible. So so that you have essentially close to 100% coverage on these annotations. This is why the security logic or SE Linux and AppArmor are probably one of the first things to be initialized, like in the kernel. Then they start sort of applying their annotations and their policies before everything else is loaded.
That totally makes sense. All right. So, audience, if you have any last questions, get typing, because we're running up towards the top of the hour. Just having a quick look back in case we missed something. We're coming back to that backup question.
Yes.
So Dinakaran followed up to say, backup in organization takes place at the end of the day. I wanted to take a backup. I wonder if that means just basically wondering whether you can use LSM as I guess as a way of automating this backup. That's kind of interesting.
Okay, I think this is. I don't know. I'm not good. I don't think I can design this in my head right now. But you may want to look at seccomp user notify, where the certain syscalls would notify you in user space, right? You will block that action, trigger your backup, and then resume that action. But like, I don't know whether that's going to work in LSM. I don't think you can block an action for that enough, because you're in syscall context. You may actually end up into races, because you have that file being up for deletion, and then you're also trying to like copy the file and back it up. You just have to try a couple of things with seccomp user notify, even with LSM or BPF. But essentially, you may want to trigger a notification and then deny the action, right? And then actually delete the file after the backup is completed. Maybe.
Yeah. Yeah. Maybe bring a bunch of that out into user space. Yeah. All right. Comment from Alan agreeing that UX should be designed around security. I think this is one of the kind of big learnings over the last few years, is how important it is to make security usable. Because if it isn't usable, people just don't turn it on. So yeah, important lesson for security tooling, full stop. Anything else, KP, that you would like to add before we wrap up today?
So I think one particular thing that is going to help in conjunction with boot, like loading BPF programs at boot time, that we are working on developing, is the ability to set attributes on files. So this is essentially when in SE Linux, you have these concept of labels. You have some labels that you can set on a file, and that security state persists with the file itself. And we want to do that with BPF as well. There are some helpers that we will write that will sort of read these extended attributes at boot time and form a context, or at boot time, or at like whenever the file is accessed, it will populate that context from the persisted information. And there are some helpers that we need to write for that we're currently in the works of. So in Linux jargon, it is ability to write and set and get extended attributes of file systems in BPF.
Wow. All right. So I think I'm not seeing any new questions coming in. So I think we will wrap up here. I want to say thank you so much, KP, for your time today, and for sharing your expertise. I've certainly, through the course of these conversations, learned a ton about how LSM works. Oh, we have got one last question. How to get notified? The support for BPF D path.
When you say notified, we already have BPF path in the kernel. So when I don't know, like, how do you get notified about kernel features? You can always come and talk to us in the office hours, and you can also say that I want like I'll generally show up if there's an office hours or somebody from my team, and then the maintainers are always there. So I guess we have a informal notification scheme of come and talk to us. But I think there is some really good things that are happening in this space. People are people write blogs. I think there is eBPF.io has some great information on what are the new changes coming up. I'm going to cover the other part of notification is how do you check if BPF TPath is available in the kernel? You can use BPF tool to do that.
Right. Yeah. And we had a really good episode with Quentin about BPF tool. He did an amazing Twitter thread with all kinds of hints and tips about using BPF tool. So that's another
I
nice.
use that Twitter thread even now. I have it bookmarked, and I use it as my BPF tool documentation. That is really great work by Quentin. It is. Thank you so much if you're hearing me, Quentin.
Okay, wonderful. Well, thank you so much again, KP, for your time. Thank you, all the audience members, for joining us and for asking lots of great questions and triggering lots of really great ideas, I think, here. So we'll be back. I think we're undecided next week because of Thanksgiving. So maybe taking a break next week. There will definitely, we'll keep you posted. Keep an eye on the Slack or Twitter. And Quentin's posted the link to his thread, which is amazing. Thank you for that. And we will certainly be back in this time slot in 2 weeks' time. So look forward to seeing you all then. Thank you and take care.
Thanks, everyone. Bye. Thanks, Liz.
Bye now.
Bye.